Welcome to this explainer. Today we're diving right into the absolutely fascinating science and the equations behind how human populations grow, shift, and completely change over time. Have you ever actually stopped to wonder how governments know exactly how many people live in a country? Or how they predict what a society is going to look like 10, 20, or even 50 years down the line? Well, today we're going totally behind the scenes to decode the mechanics of population change.
To really wrap our heads around the massive scale we're talking about, let's kick things off with this completely staggering figure: 109,035,343. That right there was the total baseline population of the Philippines as of May 1, 2020, according to the Philippine Statistics Authority. I mean, we are talking about millions of individual lives here, people constantly moving, aging, and changing. It's wild. But how on earth do we actually track a number that huge?
So here's our quick roadmap for this explainer. First, we'll hit the science of demography. Then we'll visualize the population, check out the engines of change, break down the balancing equation, and finally look at exactly how we measure all these shifts.
All right, Section 1, the science of demography and gathering the numbers.
So, what actually is demography? It's essentially the science of tracking the makeup and the shifting structure of a human population over time. It's like putting together a giant puzzle. Demographers use statistics. We're talking births, deaths, income, or even disease rates to get a crystal clear picture of who makes up a specific population. It is literally the ultimate tool for describing us, whether you're looking at things physically, economically, culturally, or even behaviorally.
Now, to gather all this massive data, demographers lean on a mix of four main sources. First up, you've got the census. This is the big one, a complete headcount of everyone in a particular area, usually done every 5 or 10 years. Then there's the vital registration system, which catches all those everyday events through local civil registrars, births, deaths, marriages. Third, we have sample surveys. These just take a smaller slice of the population to produce estimates, kind of like the National Demographic and Health Survey. And finally, administrative records, which are basically pulled from agency operations, like voter profiles or immunization records. Oh, and get this, when they do a full count, they are incredibly thorough. They even count land-based overseas workers, as long as they're within a 5-year window. And yes, even folks out at sea, the seafarers, get counted in the total population too.
Moving right along to Section 2, visualizing the population as a living structure.
Because a population isn't just a flat, boring number on a page. It's a living, breathing thing. And a population pyramid brilliantly breaks down how a society is actually structured. You've got your young dependents, ages 0 to 14, forming the base. Then, right in the middle, you have the massive working age group. And up at the very top, you've got the older dependents, age 65 and up. Just by glancing at a pyramid's overall shape, a demographer can instantly tell if a population is booming, stabilizing, or getting older. It's pretty amazing.
Next up, Section 3, the engines of change and the forces shaping those pyramids.
So what unseen forces actually cause that pyramid to expand or shrink? Well, the first engine here is fertility. And there's a really crucial distinction demographers make here. Fertility measures the actual number of live births from a woman or couple. This is totally different from fecundity. Fecundity is just the physiological potential to have kids, basically reproductive capacity. Fertility, on the other hand, is the actual event of a life happening and being officially recorded. The second engine is mortality, which is, to put it plainly, the complete cessation of life, measured by the number of deaths. And the way they track this is incredibly strict. For example, if someone is seemingly lifeless but gets successfully resuscitated, they are not counted as dead. Also, if a newborn shows even the slightest sign of life, a cry, pupil dilation, or literally just a single muscle twitch, even for a split second, they absolutely cannot be recorded as born dead. These super strict definitions ensure the data is perfectly accurate, whether we're talking about neonatal, infant, child, or adult mortality.
And the third and final engine is migration. Now, this isn't just taking a 2-week vacation. In the world of demography, migration specifically means geographic movement where someone crosses a territorial boundary to set up a brand new permanent residence. It's people literally packing up their entire lives and completely changing their geographic baseline.
All right, Section 4, the balancing equation and calculating total change.
This is kind of the climax of this whole explainer. How do we take those three engines, fertility, mortality, and migration, and mathematically calculate total population change? We use the population balancing equation, which is basically the master key to demography. And the logic is just wonderfully simple. P2, which is your new population size, equals P1, your starting population, plus births minus deaths plus in-migration minus out-migration. That one single equation dictates if an area's population is going to go up or down.
Honestly, just think of it exactly like a bank account. Your additions, so births and in-migration, are your deposits, right? They're adding to your total balance. On the flip side, your subtractions, deaths and out-migration, are your inevitable withdrawals. The entire demographic makeup of any society on Earth is completely governed by this simple balance of deposits and withdrawals. Finally, let's hit Section 5, measuring the shifts using everyday demography tools.
Because just knowing the total number isn't enough, right? We need to know the speed and scale of these changes. So how do we accurately measure this change over time? We absolutely need standardized ways to compare different years, different cities, or entirely different countries.
To pull this off, demographers use something called rates. A rate just measures how likely a specific event is to happen within a certain time frame compared against the population that is actually exposed to the risk of that event. You've got crude rates, which just look at the whole population without worrying about varying exposure levels, and then you have specific rates, which only look at the folks actually at risk. So for instance, an age-specific fertility rate is purely looking at births among women of a very specific age group. Other big ones you might hear are the population growth rate or the contraceptive prevalence rate.
Now, to see how big one number is compared to another, researchers use a percent difference formula. It's pretty straightforward. They take population 2, subtract population 1, divide all of that by population 1, and then multiply by 100. This perfectly expresses the relative difference as a super clear percentage. It tells you exactly down to the decimal how much a value has jumped up or dropped over 2 points in time.
And here's a cool little trick. To standardize all these rates, demographers use a specific geometric formula to calculate the mid-year population. When things compound at constant intervals, like over a year, they use this equation to estimate the exact size of the population as of July 1st of that year. Pinning it to that exact midpoint of July 1st is absolutely crucial. It ensures that the rates they're crunching are totally accurate and genuinely comparable across the board.
So the biggest takeaway from this whole explainer? Populations are never just static numbers sitting on a spreadsheet. They are constantly in motion, being pushed and pulled every single day by those three mighty engines of change. Which really leaves us to wonder. The next time you walk around your own neighborhood, ask yourself, how are the unseen forces of fertility, mortality, and migration shifting the very community you live in right now? Thanks so much for exploring the mechanics of population change with us.